Hello Year 11. For this week's independent work, we will be looking through some questions that you have been learning about in the last couple of live lessons with your teachers. Chiefly we'll be focusing therefore on the sine rule and the cosine rule. And I thought it would be useful for me to spend some time going through some simpler and some less simple examples of questions that can expect you to use these rules. And you can see the first of those in front of me now. You're given a triangle, it's not right-angled. You're given two sides, you're given two angles, and you're asked to work out the value of x to one decimal place. Now this is screaming at me trigonometry immediately. I've got an unknown side or angle in a triangle. And it's also screaming at me sine rule. I have two sides and corresponding opposite angles. So I know that I'm going to use my sine rule. And I have two versions of the sine rule. I have a over sine A is equal to b over sine b, or I have sine A over A is equal to sine B over B. Now I can generate one from the other just by multiplying by my denominators, sine A and sine B, and dividing by my numerators, A and B, and I'll get the same result, so I can convert between the two. But I would always, just to make my life easier, choose whichever version of the equation gives my unknown, in this case x, in the numerator, because there's less rearranging to do. So I'm going to choose my top equation here. So I have x divided by sine 38 is equal to 13 divided by sine 100. To find x, I need to multiply by sine 38, so I have 13 sine 38 divided by sine 100. None of those are values you're expected to know, so I can bring my calculator in. I make sure I'm in degrees, that's the little d at the top. I've talked through in previous videos how to convert that. If not, you're going to set up and then degrees. So I have 13 sine 38 divided by sine 100, giving me 8.1 dp, 8.1 centimetres. And I ask myself, in the context of the question, does that seem sensible? Yes, 8.1 and 13 are of the same order. If I had 1,000 or 1,000th, I probably know something had gone wrong with my calculations. My next question asks a very similar thing. Work out the value of x to one decimal place. But now I have three sides and one angle, and that angle is opposite my unknown. So I'm going to use instead my cosine rule. Now this is a rule that you need to know. A squared is equal to b squared plus c squared, subtract 2bc cosine A. Now all you really need to remember is that the cosine A and the A squared are on opposite sides to work this through. So I'm going to substitute in. This is A because it's opposite my angle A, because that's the only angle I need to know, and then B and C can be used interchangeably. So in this case I have a squared, which is x squared, is equal to b squared, 13 squared, plus c squared, 10 squared, subtract 2 times b, 13, times c, 10, cosine 100, which gives me x squared. I'm just going to type this into my calculator. 13 squared plus 10 squared, subtract, and then 2 times 13 times 10 is just 260, times cosine 100, again making sure I'm in degrees, giving me x squared is 314.1485262. Because I haven't finished yet, I need to square root both sides. So on my calculator, root answer, I want 1 dp, so 17.7 centimetres. Again, I ask myself, does that seem sensible? Well, 13 and 10 are of a similar size, so that does seem reasonable. And in the diagram this looks a bit larger, which is not a guarantee I'm right, but it tells me I'm of the right order of magnitude, which is important. So let's look at some more complex examples now. Here we have another triangle, but this time our sides are x plus 2, 2x subtract 3 and root 73, and I'm given 60 and I'm asked to work out the value of x. Now it'd be very easy seeing this question to panic. But I know that I have three sides and one angle. I'm going to use my cosine rule. So let's just start with that and see what happens. Once again, I know this is going to be A because it's opposite my angle. And then B and C can be used interchangeably. So I have a squared, root 73 squared is 73, is equal to b squared, x plus 2 all squared, plus c squared, 2x subtract 3 all squared, and then minus 2bc, that's 2 times b, x plus 2, times c, 2x subtract 3, times cosine 60. Now cosine 60 is a value you're expected to know. It's a half. So 73 is equal to, I'm going to expand these brackets out, x squared plus 4x plus 4, plus, and then 4x squared subtract 12x plus 9, and then I've got my 2 times cosine 60. 2 times a half is 1. So I've just now got, I'm subtracting these two brackets multiplied together. 2x squared plus 4x subtract 3x is plus x, subtract 6. So 73 is equal to, I'm going to group these things together. X squared and 4x squared is 5x squared. 4x and minus 12x is subtract 8x. And plus 4 plus 9 is plus 13. Then I've got this minus 1 times this whole bracket. So subtract 2x squared, subtract x, and plus 6. So 73 is equal to 3x squared, subtract 9x, plus 9t. And just by using this rule, I've got a quadratic equation. I'm trying to find x, so I know how to solve a quadratic equation. I need to move everything to one side such that my quadratic is equal to 0. So I'm going to subtract 73 from both sides. 3x squared, subtract 9x, and then that's going to be subtract 54 is equal to 0. And now I can solve this in one of three ways. I can factorise, I can complete the square, or I can use a quadratic formula. I'm going to look to see if I can make this easier for myself first. I'm going to see if I can divide by 3. 3 goes into 3, it also goes into negative 9, and it goes into negative 54. So I divide both sides by 3. X squared subtract 3x, and then that's subtract 18 is equal to 0 divided by 3, which is 0. And then I can see that this factorises. X subtract 6, x plus 3 equals 0. Now if I couldn't see that, I could absolutely use a quadratic formula, even on this part up here, and still get exactly the right answer. It would just take a bit longer. So then I know that x subtract 6 equals 0, so x is 6, or x plus 3 equals 0, so x is negative 3. But I'm not quite done. It does say work out the value, that's my clue here. If I think about my context, let's say x plus 2, when x is 6, that's 8, seems sensible. When x is negative 3, that's negative 1, which is impossible. So I need my x value to be, or indeed my x plus 2 to be greater than 0, and my 2x subtract 3 to be greater than 0. Otherwise my lengths are meaningless. And that only works where x is equal to 6. So I have my final answer. So that's a much more complex question. It'll be towards the end of a paper. But you're all more than capable of doing it. And all I really needed to do to start it off is 3 sides and an angle, cosine rule. Do a bit of algebraic manipulation. You need to be practicing that to make sure you're very fluent at this. And then I notice I get a quadratic. Solve and use just some reasoning about my context to work out the final value. The last question I want to look at is this question here. Angle ABC is obtuse. Now that is shouting out at me immediately, sine rule, ambiguous case. So if this were a question with an answer box somewhere, I would just write below my answer box obtuse. That reminds me so I don't get all excited when I get an answer. Work out the size of angle ABC. I'm going to label that on there because they haven't done it for me. And let's call that x. Give your answer to 3 significant figures. So I've got 2 sides, 2 angles, and the sides are opposite the angles. So that's very handy. So I'm going to use my sine rule. Remember that I said with my sine rule, I'll choose my numerator to be whichever part my unknown is in. So in this case, I'm going to use sine A over A equals sine B over B. Or in this case, sine x over 20 is equal to sine 35 over 12. I'm going to solve for x. I'm going to multiply both sides by 20. Sine x is equal to 20 sine 35 over 12. And I'm going to take arc sine, or inverse sine, of both sides. X is equal to arc sine of 20 sine 35 over 12. Now you'll note I've not calculated any of these values yet, because I can just type this into my calculator in one go now. So let's do exactly that. I want arc sine of 20 sine 35 divided by 12. I press equals, and I get 72.93271, and so on. Then I go to write that in my answer box, and I realise I've written obtuse next to it, and this is not an obtuse angle. I know that x must be greater than 90 degrees. So this is the ambiguous case of my sine rule, that I can draw two different triangles that will both have exactly the same values. So I'm giving my answer to 3SF. I need to bear that in mind. I need to think about the graph of sine. My sine graph looks something like this. It's a sinusoid, it's periodic. It has a period of 360 degrees. It's symmetrical, or at least these curved bits are symmetrical. And we're going between 1 and -1. And I had arc sine of this, 20 sine 35 over 12, which gives me some value here, basically, if I trace it along. And I found this value here was equal to 72.93271. And I want my obtuse angle, so I want this value here. That's what I want to find out. Now I use the fact that this graph is symmetrical about this point, at least locally. So I know that this distance here is 72.9. So I also know that this distance here between my value and 180 must be 72.9, because my graph must be symmetrical. And that's key here, because that means I can work out my new value of x by doing 180 subtract 72.93271. Now there are other ways to do this. Some of you may have met a cast diagram to work this out. Some of you may have just learned the formula, 180 subtract the acute angle. Any of those are fine at this level. I like the graph one because it draws on a lot of other understanding and explains why it works. At IB, I tend to use the cast diagram because we have more work to do with it. So, I have 180. I've kept this in my calculator, so subtract answer gives me 107.0672. And I'm asked my answer to 3SF. I should really have written that on my answer line as well, giving me 107 degrees. And I just check, is that obtuse? Yes. And therefore I'm probably along the right lines. So that's a set of questions focusing on the sine and the cosine rule. Some easy, some much less easy. Indeed, those last two were grade 8 or 9 questions easily. Good luck with your Dr. Frost maths work, and remember to ask for help should you need it.